So in this video, we are going to solve this question I have on the screen here, which says that a 50 ohm load resistance is connected across a half wave rectifier. The input supply voltage is 230 VRMS at 50 Hz. Determine A, the DC output voltage, B, the peak to peak ripple in the output voltage, and then C, the percentage ripple, and then finally the output ripple frequency. Okay, so we are going to take the first one, which is A. So you have to find the DC output, which is the average voltage. Okay, so we can use the formula. The average voltage will be equal to V mass over pi. Okay, that's for a half wave. For a half wave, this is the formula that you can use to find the average value, which is the DC value. That's the DC output. Okay, so this is the formula that we need. So we need V mass over pi. So in this case, you see, we don't know V mass here, so we can't find for the average. So for us to be able to find the average, we must know the V mass, which is the maximum voltage. Okay, so how are you going to do that? So we've been given the VRMS here, okay, which is the root mean square value. So we've been given that. So from that one, we can use that one to find for the maximum voltage here. Then we can go ahead and then solve for the average. So the formula for the VRMS is given to be equal to the maximum voltage, which is Vm over the square root of what, 2. So you can use this formula to find for V mass. So let's look at that. So you can make V mass the subject. So V mass will be equal to V RMS times the square root of 2. So we know VRMS to be 230. So that's 230. So that'll be 230 times the square root of what, 2. So that's what we get for VRMS times root of 2. So that gave me 325.26 volts. That's 325.26 volts. So this is the maximum voltage that we are looking for. So let me write that one down. So Vm, we got this to be 325.26 volts. Okay, so now that you know the maximum voltage, you can now find the average voltage, which is the DC output. So we know from this formula that the average will be Vm over pi. So we now know V mass. So the average will now become 325.26 over pi. So let's see what we get for this. Okay, so this gave me a value of 103.5 volts. Okay, so this will be the average voltage. Okay, you are finding an average voltage because it's after the rectification process has been done, the output will be pulsating. Okay, it will be going up, and then it will go up and come down, go up and then come down. So we can't actually tell the actual output voltage. So for us to be able to tell the actual output voltage, that's when you have to find the average. So that will tell us the actual output voltage. That's for the average that we found here. Okay, so now that we found for the average, let's go ahead and then solve for the remaining part of the question. So the second question says that we should find the peak to peak ripple in the output voltage. Okay, so for us to understand the B part well, let's look at these two waveforms that I have here. So the top one is for the input, and then what I have down here is the output. So this is the maximum voltage, and then this is the minimum. This is the maximum output voltage here, and the minimum here will be 0. Okay, so what happens is that after the rectification part, the negative half will be erased, so you have just the positive part. So this will be the output voltage. But I see here the output voltage is pulsating, that it is going up, coming down, going up, coming down. So it will go up to some extent, then to come down to 0, then to go up to some extent, then to come down to 0. So that's the output voltage. Okay, so we've been asked to find a peak to peak ripple in the output voltage. So for us to be able to find a peak to peak ripple in the output voltage, we have to subtract the maximum output voltage. Okay, I have to subtract the minimum output voltage from the maximum output voltage. So in this case, this will be the maximum output voltage and then the minimum will be 0. Okay, because it goes up to some extent, then it comes down to 0, then it goes up again, then it comes down to 0. So the peak to peak ripple will be the difference between the maximum output voltage and then the minimum output voltage. So you got the maximum output voltage to be 325.6 and the minimum will be 0. That's for a half wave rectifier, because it will go up to the Vmax, which in this case is 325.26. Then it will come down to 0. So the peak to peak ripple voltage, that will be the voltage peak to peak, that will be Vm minus what, the minimum voltage, which in this case is 0. So that will be 325.26 minus what, 0, which will still be 325.26 volts. Okay, so that's the voltage peak to peak here. Alright, so let's go and then solve for the C part also. Okay, so we got V peak to peak to also be 325.26 volts. So the next one you are going to find is for the percentage ripple. Okay, you have to find the percentage ripple. Okay, before I continue, let me write down the value we got for the average. So the average was 103.5 volts. Okay, so the third question says that we should find the percentage ripple. So the percentage ripple, that's like the percentage of AC voltage, okay, in the DC voltage. Okay, so for us to be able to find the percentage ripple, we are going to divide the voltage peak to peak, which is the ripple voltage here, by the average voltage. Then we find the percentage of that. So that will be V peak to peak. So that will be 325.26 divided by the average voltage. That's 103.5. And you have to find what the percentage of it. So that will be times 100. So let's see what that will give us. Divided by 103.5 times 100. Okay, so that gives me a percentage of 314.26%. Okay, so that will be the percentage ripple. So now that you know the percentage ripple, let's solve for the last part, which is the D, which says that we should find out the output frequency. Okay, so in a half wave rectifier, the output ripple frequency will be the same as the frequency of the waveform. Okay, that it will be the same as the frequency of the input waveform. So in this case, we were given the frequency of the supply voltage to be 50 Hz. Okay, so therefore the ripple frequency FR will also be 50 Hz, same as the frequency of the source voltage.